Okay, this is a question from the 2009 free response section. It's actually in the non-calculator section. So I do want to point out for this year, your questions are going to be all calculator. All right. We may get something like this though. All right, we have a graph, and it's, again, important to note whenever you get a graph, what is it a graph of? This one is f prime. And we're told the derivative of a function f is defined by f prime x is g of x from -4 to 0 and 5e to the negative x over 3 minus 3 from 0 to 4. So they're describing this graph f prime. The graph is continuous function, and it has an x-intercept at -2, so we know that's going to be a 0 there. And this x right in here is 3 ln 5 over 3. All right. We're also told that this first part is in fact a semicircle, and this is going to be important, f of 0 is 5. So from all of that, we want to figure out all the values where we have a point of inflection. Part B, we want to figure out f of -4 and f of 4. And finally in part C, we're going to find where it has an absolute maximum. So actually A and C can almost be done together because it's going to involve the same thing. So let's start there. All right, so for part A, I'm going to actually set up this kind of three-way chart that we were working on before the break here. And if we look up at our graph, there's kind of an interesting point here at -2, and maybe an interesting point here at 0, and another intercept here at 3 ln 5 by 3. That's a 5. Okay, so let's kind of get this whole thing started here. So I'm going to start with question A. We want to know a point of inflection. So remember, points of inflection are when the second derivative changes from concave down to concave up, or concave up to concave down. And that's going to depend on this particular graph with our f prime. So if we take a look from -4 all the way to 2, f prime is in fact going down. Now if that's going down, that means its derivative, the second derivative here, its derivative would have to be negative. And if we go all the way back up then, if the second derivative is negative, that means our function f is concave down. Then from -2 to 0, we are going up. That means its derivative is positive. Going up here, we have concave up. So in fact, -2 at x equal to -2, we will have a point of inflection. Now we're going down until we reach that 3 ln 5. So that is negative, and that would be concave down. So at x equal to 0, we're also going to have a point of inflection. Now after 3 ln 5 over 3, we're still going down, so that is still negative. No point of inflection here. Okay? All right, well, let's stay with this and do part C. You don't have to do these in order, you just have to get all of your answers up. So we don't have to do these in order. I'm going to look at part C here. Now, also looking at all of our numbers here, from 0 to 2, our derivative is always positive. Let me change my color. It's always positive here. It's above the x-axis. And from -2 to 0, it's still positive above the x-axis. And even here, we're above the x-axis. So looking at all those positives, if the derivative is positive, that means f is going up, it's going up, it's going up, and then finally in this section here, we are negative and we're going down. So that would mean that our absolute maximum here, And the only maximum really we have is 3 ln 5 over 3. There's where we're going to have our absolute maximum. All right, so whatever it would have been down here at -4, remember -4, we continue to go up from -4, right? We always talked about checking your endpoints, but we're going up this whole way from -4. So this must be our absolute maximum. Okay, now let's come back and let's look at letter B, sorry. So I'm going to just get rid of all of that there. Okay, so for B, we want to know what f of -4, and we want f of 4. Okay, well, we're going to have to use our first fundamental theorem of calculus. So this is our fundamental theorem of calculus problem here. Now, I'm going to bring back my picture. Okay, I got my picture back now. The first fundamental theorem is about integrals. So I'm actually going to use some integrals. I want to figure out what f of -4 is. So I want to figure out what this is over here. Well, if I set up an integral from 0, try that again. I'm going to set it up from -4 to 0 of, in this case, g of x, because it's following that g of x. It's really following the semicircle, but I'm going to put g of x dx. That means that I'm going to get the derivative of g is actually going to be f of top minus bottom. All right, so that setup means this whole thing here is my area under the curve. So it's all of this here, all of this under the curve. This is important because that's actually given to me in the question, and this is then what I want to find. So we have area, we have something given to us in the question, and then we have what we want to find. And that's important when we see these sort of questions that are going to involve the first fundamental theorem of calculus. We want some area that we can define. We want something that's given to us as part of the question, and then what we want to find. All right, so let's go ahead and find the area under this curve from -4 to 0. Well, we kind of have two parts here. I have this rectangle, so I have this rectangle here, which in fact I'm kind of messing up my picture here, but that is actually a width of 4 and a height of 2. So that's this first part, but then I don't want all of this that's actually part of that semicircle. So I need to subtract this semicircle. Now it's half of the circle, and a circle is pi r squared. So the radius of this particular circle, if that's 4, the radius would be 2. So we're going to get 2 squared. So that's going to become my area. We know f of 0 is 5, and then minus f of -4. So now it's just a matter of solving this integral and getting f, sorry about that, and finding f of -4. Okay, so going back over here, we're going to get 8 minus, well, this is 4, but then we're going to cut that in half, so that's actually 2 pi. I'm going to move this over, so minus 5, and that is negative f of -4. So we're going to have to really do a little switch all the way around here. So this becomes 3 minus 2 pi. That's negative f of -4. That's the opposite. So let's do a little switch here. And we're going to get f of -4 is -3 plus 2 pi, or 2 pi minus 3. And we go ahead and we'll do the same thing to find f of 4. Okay, so I'm going to bring back a new version of my picture again. Okay, here we got a new picture, a little cleaner again. Now I want to figure out f of 4. I want this piece right over here at f of 4. We're going to set up the same thing. Again, I want to use something that I'm given in the question. All right, so I want to use this f of 0 here. So I'm going to set up this integral from here over. So I'm going to set up the integral from 0 to 4. Now the function here is a new one, so from 0 to 4 we have 5x, e, let's clean that up, 5e raised to the negative x over 3 minus 3 dx. And that will give me f of 4, because when we take that derivative, right, it's this thing. When we take the derivative, we'll get back to f. So f of top minus the bottom. So again, we have this area kind of set up. Now this one's a little different. It's not really going to be the area. We have the equation. This is kind of funky in here. So we're going to use the equation here. We have what we want to find and what we're given in the question. So we have all three of those pieces again. Okay, so this one, that's what we're looking for. We know this is 5 from the equation, so it's really this piece right here. We need the antiderivative of this. Okay, now this is supposed to be a no calculator section, so let's see if we can go ahead and try this without our calculator. Okay, so for a non-calculator question, we're going to have to split this up. So I'm going to go ahead and split this up from 0 to 4 of 5e to the negative x over 3 and dx. And we're going to subtract the integral from of 3 dx. Okay, and we got the whole thing. So this isn't going to change. That's going to be the same kind of all the way down. Right here, we can do this piece pretty easily. Right, this piece here pretty easily, and that's going to give me 3x. All right, so it's this other piece here that's going to be a little different. Now, in fact, what we have is some u substitution, right? We got this crazy thing happening up here, so we're going to do some u substitution. So I'm going to let u equal negative 1/3 x. That means du is going to equal negative 1/3 dx. Well, we don't have negative 1/3 dx, we just have dx. So if I multiply by negative 3 and multiply this by negative 3, that just kind of cancels. There I have my dx. So now I can swap these out, and I can get now the integral. And 0 to 4 isn't really the terms here, but I'm just going to kind of keep them off to the side here because I don't want to change those right now, because I'm going to put it back into x in a minute. But this becomes 5. This is e to the u now, and instead of dx, I have negative 3 du. Remember, this is just going to stay the same all the way down. Kind of cheating here a little bit. Okay, the integral of e to the u is just e to the u, so I'm going to do kind of 2 and 1 here. This is going to give me now negative 15, right? I'm going to put these two together, negative 15e. Instead of u, I'm going to put back my negative x over 3. And I still have the minus 3x. I'm going to bring all of this down. Now we got to evaluate. Now I'm going to put my 0 to 4 back in. And that is still my f of 4 minus 5. So this is what we have set up now. Again, non-calculator, unfortunately, so it's a little bit more work. Your stuff will be calculator. we could have, if it's a calculator section, you'd just be plugging this, we'd be plugging this part just into our calculator and solving it, and it'll actually go a lot quicker. So they could give you something like this. In May, you just plug that into your calculator, and this may end up being one of those 15-minute questions. All right, let's put these values in here, the 0 and the 4. So now we're going to have top minus bottom. I'm going to get negative 15 e to the negative 4 over 3 minus 3 times 4 minus, so that's the top, minus the bottom is negative 15 e to the negative, this will be 0 over 3 minus 3 to the 0. And over on the other side, we'll squeeze it in here, minus 5. Okay, close that off. All right, not much we can do right here. We're just going to have negative 15. I'll keep that as e to the negative 4/3. This becomes minus 12. Over here, this whole thing is 0, and then we get e to the 0. That's just 1. So it looks like negative 15, but then we're going to get positive 15. And this is 0. F to the 4 minus 5. Okay, we can put these two together, and I end up with 3 minus 15 e to the 4/3, negative 4/3, and that is f to the 4 minus 5. So if I do one last step here, let's bring my negative 5 over to the other side, and I'll do a little switch too. We get f to the 4 is going to be 3 plus 5, so that is 8 minus 15e to the negative 4/3. And this one was non-calculator, so we'd kind of stop right there. We wouldn't have to go any further. If it was calculator, then we'd do this part. This would have all shown up in our calculator, and we would have listed this to 3 decimal places. But that's question number 6 from 2009, our non-calculator section.